So today we have data entropy, and the intent really is to step back from the work that we're all doing and to be technology agnostic, to think outside the box. We've got challenges at work. We're going to put it all aside. We just look at this concept of data entropy today. So you see a little rocket ship out there, and it's heading out to space. It's heading to this beautiful planet over there. Okay, so my name is Terence, Chair, and I've been a solution integration data architect for some time now. And I'd like to share my experiences as well as talk about, in particular, data entropy. So today's agenda, we're really going through a couple of items. What exactly is data entropy? It's energy. It's all around us, just like data. We're going to talk through 50 shades of data. Like similar to the book, 50 Shades of Grey. There are aspects of data that we haven't thought about, all the different gray areas. We're going to then walk through some concepts, just pulling ideas and observations from a variety of different places. And finally, then we'll go through some out-of-box thinking. What's coming up? In terms of technology, in terms of thinking that can be applied to the data sphere. We might talk a little bit about reality, what we actually do face at work. And finally, concepts and thinking that can help us launch to the future. So the slides have morphed a little, but all good. So entropy is a scientific concept as well as has a measurable property. It's commonly associated with order, disorder, randomness, and uncertainty. Energy, it really is about energy. So you might see, for example, water. In its solid state, you put energy into it, it changes its form, it becomes like water, from ice to water. And you add more energy, it becomes like steam. So things do change in its form and its nature as it goes through different levels of entropy. So one of the things that we do need to consider is measuring, how do we measure it? So if we can't measure something, we don't know how we're doing, whether it's improving, is it getting, how do we then assess that we're improving the system, right? So we've put in, I've got about 6 different measures here. There's many more. It really comes down to our perspectives of how our data is going to work for us. So we've got things like data quality, which is a very broad description of what is fit for purpose in our environment. We've got the authority of data, which is the data empowered? Is there like legislation behind it? Can it be enforced? We've got accuracy of data. Once it's available, is it actually useful, error-free, reliable? Can we use it? And then we also have a concept called truth, very different from facts that we're commonly familiar with. And we're talking about validity. So different people have perspectives of an event. But sometimes what we want to know is what actually happened and then the interpretation of that. So once we have data, we know it's valid, we know it has authority, we bring it, we know where it's come from. We want it at a particular place. That's where the timeline comes in. Is the data available when we need it? So that's a measure as well. The timeliness of the data. And finally, what are we going to use it for? Once we have the data, is it suitable? And really, is that data usable in the form that we've got it? And collectively, all these six different attributes, they form an assessment, and there's many more. We could add more ways of measuring how the entropy of this data is. Is it hot or cold in that sense? Is it usable? Is it empowered? Is it error-free? Is it valid? And is available for our particular use? So we've got the space theme going because in the future, we're going to stretch this data. We're going to talk about systems, not just on the planet, not just within our enterprise, but we're going to start seeing what happens if data is, very, very far away. It already happens within the organization. Hops of data and the timeliness is affected as it goes through an enterprise, right? So it is very realistic that in the future, when you've got a spaceship somewhere else on a different planet, synchronizing information and data is going to be a challenge. So briefly, we just have a picture of the enterprise, different aspects, the systems that we have within the enterprise. I said we won't talk about technology, but we're just looking at the different classes of information across the enterprise, right? So typically we've got like source systems, master data systems, sources of truth, data models. We store them somewhere in the organization. Nowadays we have data lakes and backups that we keep. Data lakes sometimes are treated that way, where we bring structured and unstructured data inside. We've got the traditional enterprise data warehouse. Sometimes we have data vaults, which are modeled systems. Metadata associated with these systems, typically stored in that part of the ecosystem. Data marts, where we take a segment of that data and we bring it out for a particular use case. And then reports and apps that we build on these segments of data. And in the future, Gartner's talking about a variety of different things like data fabric, service fabrics, that's coming, which is really stretching out that ecosystem from a linear pipeline to a multidimensional way of looking at information. So based on this entropy sort of map, we're just going to identify, based on our measures, what the high and low entropy areas within this ecosystem are. So, and this is my view of it. Every organization is different, and the entropy is different. Energy that moves within the organization, the sources of truth can move. So source systems, a lot of utility, master data, where you have the golden records, data models, which are a representation of your organization, data systems. They have high entropy. Things that have low entropy, data lakes, backups, and some data lakes have high entropy. But generally, when we bring data into a lake, it's in its raw state, not conformed. So generally, it's pitched as low. And then we know situations of backups are backups. Those things do exist. And it's there. So the traditional enterprise data warehouse, relational, typically highly modeled information, considered high in terms of entropy. It has a lot of data from the organization, generally well conformed, modeled, and managed. That would be considered high. Same with data vaults. Anyone tried data vaults here in time recently? No. So data vaults are highly modeled systems as well, usually modeled around a particular entity, a fact of the organization. And there's meta information that's stored across all the data systems. So data marts pitched as low because there's a sliver of data that is being applied for a particular use case. Similarly for reports and apps. And finally, for data fabric, it's something that's new and coming. We like to think, this is us postulating now, that it's going to be high in entropy because we're going to spend a lot of money on data fabric and uplift a lot of the data quality and entropy across that system. So 50 shades of gray, 50 shades of data. So it comes from that book. Have you read the book? Has anyone read the book? All right, so it's a billionaire. Yeah, billionaire having a relationship with a young girl, and it goes from a spectrum of love and caring to abuse. Sounds like how we treat our data. No? Okay. So there are many different facets of data, and I'm just bringing like 6 of them here. One of them is perspectives. So all of us have different perspectives, use cases to data. We might have the same data, but we derive different insights from it. And sometimes organizations have wildly different views of that same data. And those are perspectives, the use cases. And all of them are valid. The use cases that one part of the organization has might be different, but they're both from another part of the organization, but the perspectives are valid. And these perspectives drives the chaos within the organization. So we talk about order and chaos. I know as other folks, we really like order. We want everything exactly where it should be and where we can see it. But we're driven by this chaos that's the use cases and perceptions of the organization. And so we somehow have to manage that. A concept called the Cathedral and Bazaar. It was a paper that was written in 1999. Has anyone read that? So it's a paper that's written that sparked aspects of the Agile wave in 1999. And so you can picture, like in the streets of, Italy or Spain, you've got this beautiful cathedral that's being built. It's got, fine architecture, stained glass, and it's beautiful. It's a lot of effort's gone into building it. It's pristine. It's architectured beautifully, and that represents, in a sense, the order. It represents structure. But when you go into the cathedral, it's quiet. People will tell you don't say too much. Keep quiet. And you contrast that with the bazaar, which is around the cathedral. Tents that have just been put up, colorful tents that have been put up, people haggling, people talking, people transacting, buying and selling, and that's the bazaar. Things are loosely formed, a lot of interaction. That's where the majority of the activity happens. But both are very valid concepts. So Agile grew off this paper where we're talking about getting activity going in the bazaar. That's where it's all going to happen. So 90% of humanity typically transacts at the bazaar. Stock markets, for example, banks. A lot of these are marketplaces, as you like. Governments typically form the cathedral, standard bodies across the world. So next we have another shade of data. We're talking about data growth. So the amount of data that's coming online is not plateauing, it's still growing. It's still, you thought that the internet came, had social media, got video platforms. We've got things like CERN that are, inspecting atoms that generates, each time they run an experiment, it just generates petabytes of data. We are attempting to go off planet. So we've got the space agency, we've got a lot of astrophysics type data being generated. And then you've got AI coming along, which is doing a lot of simulations and training. None of those simulated and trained data sets are thrown away. We keep everything, throwing nothing away. So the amount of data growth is still going up. And the solutions that we have in the enterprise are typically linear. So, we set up a data pipeline, X amount of capacity, or data lake, and this is typically linear. But the exponential amount of data, that's the real challenge. And so we've got to think differently in how we're going to process this data. And so today is not about any solutions. We're just going to sit back and try to think, are there better ways of looking at this? So as I mentioned, space is on its way. I don't know how many of you believe it, but we've got an agency, the space agency, that is telling us, we're building rockets. It's in the news all the time. But it's been a while. It's been 40, 50 years since the last time we went to the moon. But maybe this time, I think we're in better shape, newer materials. And this is going to generate a whole lot of data as we go off planet. And finally, autonomy. Autonomy is rising. Why I say this is we've been through a period of globalization. We're now going through the exact opposite of globalization. COVID has locked down the planet. We also have a very different economic landscape where there were dominant economies previously. Now the world's a lot flatter. And so even managing the standards are challenging. The opinions of different economies are valid. The social media landscapes come, where opinions of everybody now matters. You have opinions that can outweigh legislation. So these are real things that is going to reflect in the data that's coming. So autonomy is rising. If we look at the investment curves for mergers and acquisitions, it actually plateaued in 2010. So since then, the amount of global investment has actually reversed in terms of total global investments. So that, in a sense, is showing that we're going to start decentralizing as countries, as enterprises. And so managing that decentralized world is going to be interesting. So I just threw this in as a description of perspectives. And this is interesting. The map on the left will throw the whole world into chaos, at least China and the US. So it's got China there, and we've got this little dot down there, which is Taiwan, right? So depending on who you talk to, whether it's a Chinese government official or other officials, this map would look wrong, right? Or right, depending how you. Same thing, on the right we have another map, and that's Australia. So once again, depending on who you talk to, how the world's oriented, will determine, whether that map gels. But all perspectives are valid, and so we're going to see a lot more of this in the future. So scale, we've been talking about different scales. We've got, first started with the one system, then we had many systems, and then we had a whole enterprise, we had multiple enterprises across Australia across the whole world. And then we've got global systems where we try to govern entire systems across the world, companies, governments, etc. And finally, we're going to go off planet and do it interstellar. I keep bringing up interstellar space for a reason, because there'll be nuances to interstellar travel that affects the data that we get today. And those nuances we can probably apply to our enterprise and learn from it. So going off planet, I love this diagram. I love the pictures. It just looks so beautiful. I went through a whole lot on Google and, just looking at different interstellar pictures. There are a lot of very creative artists out there. So we've got this little rocket, it's going, and we're going to talk about how it's going to travel. So there's some challenges associated with interstellar activity. Einstein started in 1950, talk about relativity. The theory of relativity came out there. It's talking about time, space, matter, and those three things are related. And really, data has all three elements of it. It exists at a particular time, it's at a particular location, and has a particular form. Time synchronization came very quickly on the back of that. There were experiments done in 1972 where they put atomic clocks. They wanted to know whether time moved the same place everywhere, right? So they put an atomic clock at sea level, and they put another clock on top of a mountain. And they measured time on these clocks. What they found is time travels faster at altitude. So that when they took the measurements, they brought it back. The clock that was on the mountain had progressed faster, further. It was a delta in time. So this is interesting because that proves the relativity theory that Einstein theorized. But it does show that we have, number one, we're aging faster. Sorry. At altitude in Canberra, we're like 500, 600 meters higher than the rest of Australia. It's not that we're aging faster, it's all about perspectives as well. We're just doing things slower. Okay, so just kidding. All right, so there is a difference in time, and time is essential to data. Transactions happen, and if they happen at different times, when we bring that data together, it's all not going to be very happy. So the other idea here is the twin paradox, which is about relativity as well. Which records, when we bring that data together, is valid? It's once again a matter of perspective. The twin paradox is we had two twins, and we put one in a rocket ship and sent them off to a faraway place, and the other at near light of speed of light, sorry. And we had the other on Earth. And over time, the return trip, one would have be the regular age, let's say 10 years older. The other one would have age differently, and at the speed of light, in theory, it would have that twin would have aged slower. So that's going to present time synchronization challenges as well, with systems that are going at different places, interstellar systems. That's going to be really interesting. I also watched this movie called Passenger. We're not going to take movies and take them for truth or fact, but Passenger was a very interesting movie with Chris Pratt and Jennifer Lawrence. And has everyone seen that? Yeah. I recommend it. It's got really good, like the spaceship looked really nice. Okay, it's good. So anyway, they're sending this spaceship out to space. It's traveling many astronomical units away from Earth. Something goes wrong. They wake up one of the passengers. That's Chris Pratt. He gets off out of his sleeping pod. They're all going to hibernate because the journey is going to take like 100 years to get to this new Earth. So Chris Pratt wakes up, finds that he's the only person on the ship that's awake, and he's gonna age and die before he gets to that destination. He gets the little dashboard. He goes to their console and says, "Help!" Sends a message to Earth to say, "What do I do?" And the computer tells him the message will take about 19 years to get to Earth, and it'll take 22 years to get the answer back, because they would have moved further away from the Earth. The message would have taken longer. So that's Chris Pratt's dilemma. This communication in space, if it takes that long, it's going to be a problem. So along comes Star Trek, and you've heard Star Trek, subspace communication. What exactly is that? Is it fiction, or is it actual? It's possible that it could be reality. So I did some research on that subspace communication, and it came out with something called quantum entanglement. So it is possible that if you have a spaceship very far away, the whole quantum theory talks about atoms that you can synchronize at distance. So Einstein talked about it, and he called it spooky action at a distance, right? So quantum entanglement, and it's coming, by the way, the technology. They are able to synchronize the communications between two atoms at around approximately 1,000 meters. And it's coming. Quantum computing, all this is kind of related. So the intent of quantum entanglement is now you're able to communicate at distance. So the challenges that we have with space, as daunting as they are already, that communication challenge might still be manageable. So we bring it to the enterprise, and when you've got a system that's moving data from one side of the enterprise to the other, it takes a couple of days. It's not so bad. Mm-hmm. Yeah, but we can definitely improve that still. So I'm going to throw in some concepts today, just to step away from all the things that we've traditionally known, and just explore a variety of concepts. And not all of them are there. There's some that are in your heads as well. We're going to throw them in. We'll keep growing on this list of concepts and percolating into useful thinking. So we talked about exponential scale already. We talked about going off planet. It's something that I observe, which is history is typically written by the people who write the books, typically victors. We're going to look at things like truth versus fact. Is it the same or is it different? So increasingly, because of these perspectives, people are looking beyond just what's presented as facts to what actually is the truth, the reality. And financial systems are facing those kind of challenges today. So a long time ago, when you sent money abroad, banks have to manually reconcile information. They needed to have the equivalent money at the destination before that transaction could be made. So truth now is verifying if those quantums of money exist at the destination. Truth in many other areas, not just finance. Another thought here is group thinking is dangerous. Does anyone think that's the case? In Australia, we're fairly liberal thinkers, so it is the outcomes of people thinking the same all the time, it's not good. End up with sometimes like lemmings going off the cliff. Systems thinking is interesting. And if you've been exposed to systems thinking, it's talking about that a product's not just the sum of its parts, but now we're diving into the details, but the sum of the interactions associated with it. So there's a lot more holistic thinking. There's things to glean from that space. Complexity productivity. We know that as complexity increases, sometimes productivity does take a hit. We'll also we'll talk about complexity and productivity in the next few slides as well. And we'll keep going now just to go through these list of things. Distributed versus centralized. So we've gone through a period of centralization. A lot of our systems are centralized by the nature of which we do things. That we're project driven, we like to manage and govern things, so we have to centralize them. But very valid with blockchain and Bitcoin driving a lot of significant new investments into decentralization. You can see that there's a lot of interest in that space. Moore's law, which is number of transistors that we can fit in a chip, that's every couple of years is supposed to double. And I used to work in a semiconductor factory, and at that time, it was like probably 10 years ago, it was 10 nanometers. Now there are lawsuits between semiconductor factories over 5 nanometers, but the technology is capable of up to 2 nanometers in terms of the size of a transistor. An atom, in comparison, is at 0.1 nanometers. So that's pretty much where we're going to stop. We can't go any more smaller than 0.1. And that's already, we're kind of pushing it. So how long will Moore's law hold up? We'll see. It's held up for the last 20 years. But I don't think there's a lot more we can do in that space. So fortunately, quantum computing and all that, that's coming. So the way we do scalable computing is going to be very different in a couple more years, I think. Probably like 5 to 10. All right. I also play computer games, by the way. Anyone plays computer games here? It's great in winter. You just... so two of the games that I tinker with is EVE Online. EVE Online is a really interesting game. It's spaceships, huge armies, smashing it out in cyberspace. If you read the news, there was a huge battle. This was a couple of years ago, 7 years ago, where close to like $100 million worth of assets were destroyed in cyberspace. So these were two huge corporations just smashing it out in the virtual world. But what it shows is the scale of which this EVE Online was built out of Iceland, sorry. Small country was able to create this amazing game. So do give it a shot if you see it. One of the things that EVE Online brought out are nodes of infrastructure. How do you scale and manage these huge numbers of people playing and the objects inside this world that are just generating so much data? How do you decide the outcomes of who lives and who dies in this virtual world? So concepts of being killed by lag, which is my network's slower, we're further away from where all the servers are, for example, in Australia. And so the decisions being made are a little slower. So you're killed literally by network connectivity. In the future, we're going to be, the data that's traveling, if our data is inaccurate, it's not timely, we're going to have those challenges as well. We're going to be making decisions on data that might be an hour old or days old. So in the case of a spaceship that's traveling, 19 years away from Earth, it has to be autonomous enough to make a decision based on what it knows. And it can't wait 19 years for communications to come through so that it can act. So, and then, on top of that, we build AI, right? So we're going to build algorithms on what we currently have with incomplete data. It's going to make decisions that it's going to affect our lives. So it's very important to note all these things because it's going to affect us. So here is complexity productivity. How am I going for time? So very quickly, that green line represents monolithic systems. It's great when complexity is low, but when complexity goes up, it takes a big dip. Microservices, on the other hand, takes a slightly less dip. As we break complexity up, spread across the organization, we have a better chance of dealing with complex systems. The graph on the right basically tells us to bring things to the green zone, which is simple and easy to make decisions, where we can get agreements done. The things we don't want to do is go to the top right, which is bad. Complexity theory, I looked this up. There is an entire world about complexity, people that just think and talk complexity. It does have sub areas as what we just talked about, things like systems theory, systems thinking, things like nonlinear systems, changing the way we look at the world. There's a lot of self-organization, which are really, systems are a reflection of our legislation. Systems are a reflection of the organization, the culture of the organization gets built into our systems. So complexity theory, there's a whole domain there. We won't go too deep in there, but it's definitely worthwhile looking at. So a little bit of out of the box thinking, a little astronaut, a little teether. He's definitely out of his element, but he's going somewhere. So very quickly, once again, this is not a conclusive list. There's plenty more thinking out there. I'm just sourcing it, bringing it into one place, presenting it, and we can add to it in discussions after this. So brute force is not advisable. We can't just keep hammering at the same nail, at the same problem, with the same tools, and expect a different result. So sometimes we call it insanity, but we shouldn't do that. So we have to find a different way. That's basically what it is. Change is constant. If there's anything that's consistent over time, change has been consistent. There's always going to be something new. It doesn't have to be years, months. It can happening very, very often. We've got to relax our rules. Sometimes we talk about 80-20. Sometimes we might be making decisions based on incomplete data. So 60-40, these ratios would change. You don't want medical systems to make decisions on that basis. So it's case-by-case basis, or based on requirements of the use case. Crowdsourcing, user-defined stuff has plateaued. So when we talk about crowdsourcing, things like wikis, like Wikipedia, where people edit it, we've used up everyone on the planet. Everyone's editing, right? Everyone's on the phone. Everyone is actively engaged and contributing to information. So it's pretty much plateaued. As many people as we tried connecting into the ecosystem, I think we've pretty much done a good job in that area. So using that way of getting things done, crowdsourcing, is no longer the way that we move forward. We have to find something that's different. Maybe AI-enabled ideas. Infrastructure, clouds come. Canberra is coming to the party. Blockchain's on its way. So infrastructure has inched us forward a little. We're also definitely going to look into blockchain more often in the near future. So I know there's multiple organizations getting involved in that now in Canberra. So blockchain is just distributed inherently. Cloud is still centralized. So we should improve designs, improve our models. Designs are, instead of being resource managers like architects, we should start architecting, which is designing. Same thing with data models, same thing with AI models, any sort of models. Organization structure, as I mentioned earlier, we reflect that in our systems. So evolving a culture, evolving the structures of an organization will actually change the way we do our work. And finally, consider quantum computing. It's on the way. We will definitely get to it. So I'll send the slides around, but literally that's just an idea of what's the difference between the two ways of getting things done. Quantum computers have a high error rate for now, need to be kept really cold and cool. Classical computers are more accurate, so that's why we use them. They can operate at room temperature. This is our reality. So that's the height curve, and different technologies cycle through it. Things that have already been established, enterprise data warehouses, cloud, data lakes, blockchain is established, believe it or not. AI is on its way. And then data fabrics being hyped up right now, followed by integration fabrics. Quantum computing is on its way up. I've got standards and legislation there. It's constantly evolving. It's constantly work in progress. The blockchain has a concept called the Decentralized Autonomous Organization, DAO. Google it, but it talks about voting as a mechanism for making decisions. So the stakeholders get involved, they decide, and it becomes literally legislation within the blockchain world. But standards and legislation, traditional standards and legislation, they're probably going to evolve. They're probably going to drive new things in that space. And then security fabric. So let's launch into the future. We said we're going to harness some of these ideas, use them where we can. There's no specific ideas related to, oh, I've got to buy this product tomorrow, or I've got to do exactly this. But what we're looking at from a launch to future is it's how to manage autonomy. And that's an oxymoron, right? Autonomy, people don't want to be managed, they want to be independent, they want to, but governing it, managing groups of autonomous systems, that would be what it's really about. We're going to leverage the technology, which we went through a whole list earlier on. Leverage people. People are still essential to the whole construction of systems, pipelines, new technology. We definitely need to enable those. AI models and blockchain, I put them all in one, but really it's like intelligent systems. A lot of effort goes into data models, I know that. Definitely AI models, similarly for blockchain. Be like water, stay agile. That's very important. Change is the only constant. So when we design things, we should design with change in mind. So things built so that we can actually change it in the future. So that's really engineering for change. And that's where I conclude. So there's no magic bullet here, but definitely very useful things for us to consider as we head back to our organizations. Thank you.
Thanks, Terence. Any questions?
Terence, so in terms of our day job, okay, how should we take your inspiration and apply it to our day job? Right? You know, what can we do practically that's better?
So, engineering for change. That's definitely one of the two things at the bottom. Engineering for change is one. Being like water, being flexible is another, and it's flexible all the way through, not from culture, people, systems, everything needs to be flexible. So the data fabric, which is being promoted these days, we're talking about that. We don't want to stretch a fabric until it tears. And we're going to see it like a heat map. There'll be different areas of high entropy, other areas that are a little not as high. And it's all valid. They all form this fabric that keeps the organization. So yeah, engineering for change, stay agile.
Is centralization dead?
Uh,
In its architectural or governance or?
It's hard to, no, I don't think it's that. There's always a need for for governance. Centralization is a different thing, but definitely governance. Someone needs to know where we're all going. But governance will evolve to, we don't know who knows best. Is it AI that's going to decide 10 different decisions? Which one are we going to pick? Is historical AI is typically trained on historical data. Decisions that were made in the past, are they valid for what we're going to encounter in the future? We don't know. So governance still needs a human element. I think COVID is one example, because I don't think a lot of people really understand what's going on in that space. But yeah, governance is definitely not dead. It's here to stay.
Any more questions? Well, thanks, Terence. Thanks a lot.
Okay.
Thank you. Good to have something out of this field, whatever. Normal data governance or data modeling or anything like that. So I think over there for the drinks and some food will be arriving soon.
Trolleys.
Coming here or over to noisy secretary.
Because if you're in data governance, you want everything to be ordered. I mean, bring back the mainframe. We had a lot less problems in those days. That's true.
Talking about spaceships, I was watching a program on the weekend. And it was about this spaceship that somebody made, a Finnish architect in the 1960s, you know, with
Thank you, thanks.
Finnish architect made a spaceship meant to be